Today we are going to discuss a very important concept called Hugging Face models and fine-tuning those models. What exactly is this Hugging Face and what are these models? Let us get an idea on that. First of all, now we are reaching very close to generative AI right now. Until now, whatever we have seen is almost like generative AI prerequisite. So generative AI is not a field that you can learn independently. Directly jumping onto generative AI is impossible. Let us suppose if I do not have if I do not have any idea, directly getting into generative AI is no way it is possible. It's not even possible. The reason is generative AI is an advancement of deep learning, which is an advancement of machine learning, which is a kind of advanced version of your simple predictive models, which these simple predictive models started from basic reporting. Earlier, we used to do descriptive analysis. Then we slowly moved to predictive. Then we moved to machine learning algorithms, then deep learning algorithms, then now generative AI algorithms that we are using right now. And this is almost a huge amount of prerequisite. There's a huge volume of information that we need to cover before we even get started with generative AI. Okay. What we need to do is we need to at least understand what are all the important concepts within the space of this prerequisite of generative AI. If you take this very seriously, if you want to know in depth of everything, it may take almost like 2 years. If you just want to scratch the surface, look at almost everything in machine learning, almost everything in predictive modeling, everything in deep learning, it may take 6 months for us to get a complete idea. While I suggest that somebody who is very serious about generative AI, it is better to invest 6 months of time and first complete this, then only go to generative AI. So generative AI prerequisites, I would say deep learning is a prerequisite, regression, logistic regression, basic predictive modeling is a prerequisite, your validation, machine learning model validation, basic statistics, decision tree based model. These are all the prerequisites. And as I told you, this is almost like very huge amount of information, and it's not that easy to conquer it before we go to generative AI. The biggest issue right now, if you ask me about personal experience, people who are learning generative AI, the biggest issue that they're facing is in this prerequisite, like where to start this generative AI, where to start it, how to start this generative AI, like how do we learn, what do we learn, what is that we have to learn, what is that we have to avoid. So that is the biggest problem that people are facing right now. Because from anywhere, like while speaking about generative AI, people will directly use what to wet, or people will directly use a term called neural network or a layer. People will directly use a term called overfitting. People will directly use a term called cross validation. Like, what are the points that we need to look at, which are like absolutely bare minimal that we have to learn? That is what I have covered until now. So, whatever is required for generative AI, I'm not saying that I have covered this whole space. It's impossible to cover it in a short span of time. But whatever we have covered here, that will make sure that you'll be able to follow generative AI smoothly. Or anything that we are going to discuss in large language models related to generative AI, we should be able to understand. At least the language side, you should be able to understand. For images, we may have to cover convolution neural networks also. But ignoring that, for the large language models within generative AI, there are two parts. One is the language side, the other one is image side. For the language, whatever is required, those are the topics that we have covered. And I have to be honest with you, I did not go very much in depth into all of them. I have covered only that much that is required for you to understand generative AI. So there were some questions that were asked in this. For them, the answer was right now that is not required. Maybe just try to understand this concept, because you will realize that when we are going through generative AI, we have only covered that bit that will be helpful for us to understand the generative AI algorithms and large language models related exercises and the problem solving that we are going to do with it. Okay. So my whole point that I'm trying to drive here is we have only covered whatever is important for us to proceed forward. But in reality, you may have to learn much more than what is covered in this classroom later on. You try to look at this whole learning of generative AI, like the mistake that we tend to do whenever we are learning anything new. Let us suppose I want to learn C++, or I want to learn React, or I want to learn JavaScript, or I want to learn machine learning. What we need to do is we cannot look at this whole C++ as one subject and I want to learn it. We cannot look at this whole generative AI as one subject. I want to learn it. The mistake that we do is I want to learn generative AI. But you have to plan it within generative AI or within C++ or within Python. Whatever is the new topic that you are learning, there are phases. You can learn the basics as a beginner. You can learn intermediate concepts. You can learn advanced concepts. We cannot mix them. Whenever you are learning any new topic, make sure that you are not mixing all these three topics. When you are learning basics, You should not be talking about advanced concept, because once you understand basics, then you will get an idea, you'll visualize something in your brain, then you can actually follow few of the terms and topics, and then you will cover intermediate topics, which is a little advanced than the basics. Then you will learn something new. Then when you go to advanced, then you will understand what exactly is the meaning behind everything. But in the beginning itself, if we see this as this whole thing as one pie, and if we try to understand it, we'll not be able to digest. So what we are doing in this course is I'm trying to cover the basics first, then the intermediate steps. Right at the end, we will go to the actual theoretical advanced topics. Okay. There are a few topics that I have kept for later on, let's say something like transformers or attention and so on. We will get to them, maybe not right now. We will try to go step by step, phase wise manner. Okay. For example, if somebody wants to learn mathematics, I know that in mathematics, derivative is important. I know that in mathematics, calculus is important. But initially, I will be teaching them addition and subtraction. If somebody asks me a question about calculus in the beginning itself, we have to tell them that we have to wait first. We have to master all this. First, we will master addition, subtraction. Then we'll go to the limit theory. Then we will go to the derivative and all those integration, etc. That is the approach that we are following here. Now, coming back to our course, we have covered some of the topics. The last topic that we have covered is our converting words into vectors. And then we have also covered deep neural networks. Almost every large language model that we are talking about right now is a transformer. Now, what is a transformer? Transformer is a very large language model, or transformer is a very deep neural network. Almost every transformer is a deep neural network. So we have discussed deep neural networks. What is a deep neural network? What is a deep neural network? A deep neural network will have input layer and multiple hidden layers will be there. Hidden layer 1, hidden layer 2, hidden layer 3, hidden layer 4, multiple hidden layers with multiple hidden nodes and the output layer. So almost every transformer, extremely high number of hidden layers. It's not just hidden layers. There are different type of layers that are added in it, which will be used in giving our prediction, which is like very accurate. So what you can think of every large language model is a transformer architecture. What is a transformer? Transformer is a very deep neural network. Right at the end of this course, I will also explain what is this transformer architecture. How come it takes input word embeddings and gives us the output probabilities, which are in a very accurate manner. So this is a large language model. Behind the large language model, this is the transformer architecture that we are seeing, and there are different layers that are added. These layers are connected, etc., etc. So, but maybe right at the end of this course, I'll also go through this transformer architecture. I'll explain each one of these one by one, one by one, one by one, one by one. Everything we will go through it very much in depth. But as of now, we will take that I have a large language model behind the scenes. There is a deep neural network model that is working, which is giving me very high accuracy. And we have discussed some of the paid versions of the large language models. What are some of the non-open source paid versions of the large language models? OpenAI is a paid version of the large language model. We have seen one of the open source large language model, which is Cohere. Now, when we were discussing, when I first introduced large language model, there was one interesting question that was asked by somebody, that our company wants to deal the data in a secured manner. We cannot send our data to OpenAI and get the result. We cannot use the API of either OpenAI or Cohere because our company is very much closed. That means everything should be within the company only. Security is a very big deal here. If that is the case, can I download? Can I download any of the open source version of the large language model? Yes, you can download the open source version of the large language models. You can actually literally download .h5 file, which is a model extension format model file. You remember .h5 file, somewhere we have saved one of the model in .h5 or .pmml file or .bin file, binary file. So you can download, I think, .save tensors, like different type of extensions are there for models. We can download them and we can save them locally. We can use them. So what are some of the open source LLM models? How do you access them? One is through APIs, or how do you literally download them, use it personally? Has anyone stored all those open source large language models in one place? Yes. So all these open source large language model, Microsoft, imagine if you take OpenAI right now, what is the version of the OpenAI? What is the version of ChatGPT that they are using? Which version of GPT they are using right now? Right now, I think 4XO or something, right? 4XO, yeah, 4XO is what they are using. Earlier, it used to be GPT-4. Before that, it was 3.5. Before that, it was 3. Before that, it was 2, GPT-1. Now, right now, they are using this. What happened to these models? They are kind of shelved, isn't it? Nobody is using them. Now, what these companies are doing, Maybe since nobody is using, let's say, GPT 1, 2, 3, they will actually make them for free. These are some of the old models. They do not want it. Like they can, like if they feel like, they can actually make them free. They can make them as open source. We can download and we can use them. Similarly, Microsoft or similarly Google. Let's say right now they are using Gemini. Before that it was Bard. Before that some other model. Now, what if these are the top two models right now they are using, the old versions, if they want to make it open source? Is there a location where all these models are stored? Yes, there is a place called Hugging Face Hub. On Hugging Face Hub, you have all these models that are provided by OpenAI, Microsoft, Google, Meta, all these companies, their internal models, whatever they want to make it open source, they come to Hugging Face and they host them on Hugging Face. People like you and me, we can download them, we can use them for our purpose of the work or for purpose of the problem solving. So if you're working with large language models, you must be very comfortable with Hugging Face Hub. It is not necessary that always you have to use the most cutting edge model that a company is providing. Maybe your problem is not that very big problem. Maybe the problem statement that you're solving can be very easily solved by the old version of the same model. In that case, you can download that model from Hugging Face Hub and you can use it in your purpose. So Hugging Face Hub is a repository that has all the pre-trained, several pre-trained ML, NLP, vision-based models. Several models are not only just large language models, vision-based models are also available there. You can access various models and datasets from Hugging Face. In fact, if you have built a model, you can upload that as well. You can upload that and rest of the people can also use it. For example, for a particular problem statement related to credit risk, for a particular problem statement related to healthcare, you have built a model, you have fine-tuned it very well. Then if you feel that that can be useful for the others, we can also host it there. Okay. So Hugging Face is a repository of all the machine learning and AI models. So let's go to Hugging Face right now. I'll show it to you. How does that look like? So this is the Hugging Face. If you click on this Hugging Face and if you click on models, these are all the models. How many models are available right now? These are all open source models. How many models are available? As you can see, there are 727,000 models are there. And almost all the big companies, let's say Microsoft. Microsoft has given several models. These are all the models that are shared by Microsoft. Meta has given all these models. Let's say Google has given all these models. Let's say OpenAI. These are all the models that are being shared by OpenAI. Several pre-trained models are there. Some of the models, like if you see on the left-hand side, these are the tasks. Multi-model means you can do multiple tasks, like you can work with language data, you can also work with image data, or you can work with sound data, you can work with video data. So computer vision based models are available. Natural language processing models are available. Mostly we will be working with natural language processing, NLP based models. Text to speech models are available. Tabular and reinforcement, different type of models are available here on this particular Hugging Face Hub, model hub. This is known as. You have several data sets also available. If you want to challenge yourself, there are like quite large data sets are also available. You can download them and you can work on them. Like some of them are in gigabytes, some of them have billions and billions of rows. Okay, not only millions. But mostly I have seen people using models shared by Meta, OpenAI, Google, and Microsoft. Let us suppose if I have a particular model, let's say Google Gamma. Let's say this is one of the model that has been shared by Google. And what does this contain? This is a gated model. Gated model means not everyone will get the access. You have to accept some terms and conditions, then they'll give you the access. First of all, you have to create a login on Hugging Face Hub. And then this is the model that you have, Google Gamma. Then what does it do? It's this Gamma model card will give you an idea on what exactly this model is doing. Is it a text classification model? Is it a question and answering model? Or is it a text generation model? Or is it an image based model? All that information is given here. Apparently, this is a text generation model. And this is a simple interface that you can test it right here. My name is Julian and I like to, if you say compute, then make things. I have background in computer science. I have been working on video game. And then you develop further. Let's say if we say the best way to start a day is, have a good breakfast. We have wide range of breakfast options to choose from, like whatever is the text generation that is happening. And how many parameters are there in this model? How many parameters are there? Can you get an idea? The model size, the number of parameters are 8.54 billion. You remember on day one, somebody asked a question like, what is a parameter? Now you got an idea on the parameter, the number of weights that we have, those are known as parameters. Apparently, in the assignment that you have done earlier, nearly 1 million parameters are there, roughly, I guess 1 million parameters. But here we are talking about 8.54 billion parameters are there. So this is one of the model. If you want to get an idea on what are the files, you can actually download this model. There are multiple versions of this model you can download. 4.98 GB is the size of this model. And I think sometimes for here, the model extension is given as safe tensors. In some cases, you have different versions like bin file will also be there. Sometimes you have .h5 file, which is like model weights will also be provided. So you can literally download these models and you can use them locally inside your computer. If you feel this is very important for you to work in a closed environment where your company doesn't allow you to work on the online models, we can actually download them and work with them. If you want to work with these as it is, let's say right now they are on Hugging Face, we're going to see some examples like directly from Hugging Face, we can access this model and we can use this code. This is a code that will give us the output. That means we can use Google Gamma 7B model by sending our data on Hugging Face itself, and we can get the predictions directly. We can use almost like an API by sending our model, by sending our data to this model will give us a response. So what we need to do is we have to go to the models and then we have to select what is our task. Let's say my task is text classification or sentiment analysis. These are all the models. Generally, I tend to order them based on the most downloads. So these are the ones that are mostly downloaded. I can choose any of the model and then I can use it as an API using this code. So somebody simply wrote COVID cases are increasing fast. The label is given as negative. So here, this is just an interface that we are checking right now on the website, but in reality, we will be using this particular place. This is the one that we will be using in reality in our problem statement, in our code. Inside the Python code, we will be using these deep neural network models, which are known as transformers. The library name, the Hugging Face library name itself is known as transformer library. So we will be calling the transformer library, which contains all these transformer based models, which we can access. We're going to see several examples of that. I'm just giving you an idea on what is this Hugging Face and Hugging Face model hub. So all of you create a login ID on Hugging Face that is required right now. Quickly create a login ID. Once you have created a login ID, give me a confirmation. Done. So the package that will help us to access all these models, the package name is transformers. Transformers is one of the package in Python that will help us to access all these transformer based large language models. So this package has been created by Hugging Face itself. Okay. It supports developers, research students, engineers who wants to access these large language models. And it contains several large language models, all those lakhs and lakhs of models, all those thousands and thousands of hundreds of thousands of models that we have seen here. Any model that you want to access out of this, you can use this Hugging Face transformers package. Let us do one example. Let me share the code file with you, and then we will get into the coding part of this. I'm sharing the code file in the chat window. Later on, the same code file will be uploaded onto our LMS and in the document. All of you, you have access to the code files and the videos even after the classroom, right? All of you, you must be having the access, right?
Hi, sir. This is Amrit here. I don't have access yet.
Why?
I have contacted Sajid. Probably he'll give today or tomorrow.
But I'm uploading them in the document as well. In our group, I have shared one important document. In that, you must be having the access. I will checked it. Just check that, okay?
Yeah, sure. Thank you, sir.
So that is the code file link. Open the code file, all of you. This is the code file that I'm talking about. You have to install the packages. Transformers is the library that will help us to work with all these Hugging Face based models. So pip install this accelerate and so on. This will help you to execute this code quickly. Internally, all those NumPy arrays and all those data vectors that we have stored, they can work quickly with this accelerator and so on. And these are the packages that we will be using regularly. And this is an optional piece of code, like the output that we get. I want to wrap it. This is called text wrap. This is optional. You can ignore this as well. Once you're done with this installation of those packages, then we will write the code one by one, one by one. We will try to write the code quickly. How to access the Hugging Face models is what we are going to see. Once you're done with those package installation, give me a quick confirmation in the chat window. So for me, the packages are still installing. It is going to take, I think, 2 minutes of time. You will get an error like this, but that is still fine. Even with that error, we will be able to execute the code. So even if you get an error, there's no problem. You just let it go. Now let it run in the backend. Let the execution be happening. Let me explain you the code here. So what we need to do is from transformers package, we have to install something called pipeline. We have to import something called pipeline sub package. This pipeline, actually in reality, we have to write a hell lot of code. Let us suppose if I want to use a particular package, let's say something like this one. For using a particular package, I have to write lots and lots of lines of code. This much of code is needed if you want to use a package. But if you are using pipeline function, what it does is it will create a lot of code internally automatically for us. For example, if you send your data, you are supposed to tokenize that data and then you send it to the model, and the model will give you the output in probabilities. That model need to be processed later on. That output need to be processed. The output given by the model need to be processed. Then you will get your final output. You have to do a lot of tasks if you're not using the pipeline. But if you're using the pipeline, it will automatically take care of a lot of things. So we will see with pipeline, which is the easier way. Later on, I'm going to also show you without pipeline, which is the harder part. Okay. So let us see if I'm using pipeline. If I want to build sentiment analysis, what is the procedure? Let's say I will say my sentiment analysis model is equal to, I will write my pipeline. Pipeline is the function name. And then you have to mention something called task. The things that you see here on the left-hand side, these are known as tasks. Like there are different model for different tasks. You have a text classification task, you have token classification task, you have table question answering task, you have text to image task. You have to mention the task. I will also give you a list of all the tasks that a particular package or a particular model will take. So here in pipeline, the task that we are using is sentiment analysis. Okay. So you can write the task as sentiment analysis. If you see the pipeline function, you will see in its documentation, different type of task it can do. Let's say audio classification can be one task. Audio speech recognition is one task. Mask generation is one task. Table question and answering is one task. Like that, different tasks can be given as input. Right now, I want it to do sentiment analysis. Okay. My Senti model is equal to pipeline of this one. That's it. Once you do this, your sentiment analysis will be done. So it says no model was supplied. For sentiment analysis is also known as text classification. So text classification, sentiment analysis, both of them go by the same name. It's just an alias. So if I click on text classification here, that is my task name. There are 64,341 models are available just for text classification or sentiment analysis. I have not mentioned any model here. So that is what the message that I'm getting. You have not mentioned any model. There are 64,000 models are there. So default model will be taken. By default, what model it has taken? Distilbert model has been taken since you have not mentioned the model. We can mention the model also. Here we can add an extra parameter and say, I want to use a particular model as well, which we will see a little later. So right now, this is the model that it has downloaded. It has downloaded that model, 268 MB. This much model is downloaded. Now your model is ready. Cinti model is ready. So you just say Cinti model, and then whatever is your, you know, sentence or whatever is your review, you can write it here. This is a good movie. Let's say I like this movie. Now all that we did to build this sentiment analysis model, we said from transformers import pipeline and then pipeline task. That's it. Within 3 lines, you will have one of the best model. The accuracy of this model will be quite good, damn good. There's no doubt about it. Same way, let's say if I write Senti model, this is a bad movie. I did not like this movie. Negative review. So you can give the model as well, or you can mention it just with the task. Automatically, the model that is given as default for that particular task will be picked up. Let us suppose if I want to mention my particular model here in this particular example, I have taken earlier my model as it is. Now I would say my Senti model 1 is equal to, I'm mentioning the task, but here I also want to mention my model name. So I'll go here and let's say I'll go to Hugging Face models. I will choose my task, which is text classification. And this time I want to use my particular model. Let me arrange them based on most downloads. So you have Facebook, this is the most downloaded one. You have Twitter, Roberta base. This is also second most downloaded. And what if I want to use this model? Somehow I feel that my data is Twitter based data. And this model works better than the previous model, which was a Distilbert model. But I want Twitter model. So if you click on this, copy the model name. And all that you need to do here is you write my model is equal to, in this one, in the codes, you paste whatever you have written. Now this will be your model. Now if I write, now this model is getting downloaded. Once this model is downloaded, you write my model and whatever are your, let's say, overheating issue. Don't buy this product. This is a waste of money. That's what somebody has given as a tweet. Overheating issue, don't buy this product. Camera was good. Looks like there are positive as well as negative. That is why it is given as neutral. If I say camera is also not good, then this will be given as negative. This is negative. Let's say if I say again my model, let's say if I say it's a waste of money. These are all tweets. That means they will be slight small. Let's say if I say my Senti model, nice product under 20. These are some of the comments that I have found on Flipkart for a particular mobile phone, as it is if you take. So basically, if you have a website, they don't really need to build a model to do all this. They can just call this API. As soon as somebody writes a particular comment, you can directly give it under it, whether it is positive or negative or neutral. So this is the pipeline function from the transformers package. Let me clear all the output. All that you need to do is from transformers import the pipeline function. What does this pipeline function do? It will take your input, it will convert it into tokens, it will give that input to the model. From the model, it will get the output. That output will be converted into your reader friendly positive, negative, or whatever are the labels, and then it will be displayed to you. But later on, when we are fine tuning our own models based on our own preferences, then we may have to get rid of this pipeline. We have to do a lot of things manually, which is coming up. Quickly do this, all of you.
Venkatesh sir, the packages are not installing, getting error.
You will get an error. Okay.
Okay.
Even with that error, it will be fine. Okay.
Okay. Thank you.
Sir, apart from that label, there is a separate thing called score. What is that actually?
I think it is some kind of probability. What is the probability of that being positive? Like every output that we get, it will not be just a label. There will be a probability before that label. That probability will be converted to label. Sometimes that score is also given, but we are mostly focusing on the final label. So basically, this is negative. The probability for this to be negative is 0.99. That means there's a chance that it is positive also. That is 0.01. Like that. All this is known as zero-shot prediction. What is zero-shot prediction? Zero-shot prediction means without giving our whole data, without training this model particularly on our data, the model has already learned previously using different sets of data. And then by giving our data directly without any previous examples, it is going to give us the best output. This is known as zero-shot prediction. We did not give any examples. We did not expose any examples from our data set, but still you get a good result. But that may not be true in every case. If you're working with a very niche problem, this model may fail, which will require us to do fine tuning. That also we will learn. These are just simple examples that I have shown. For example, if you have a larger data set, let us suppose I have this data set, which is user reviews data. So these are actual reviews. And this is how you would like to use in real world, isn't it? I have this user review data. And what I want to do is I want to use these large language models to take care of this prediction automatically on its own without like, until now, when I give this data like this to you, what we have done, we have taken this data, we have built a word-to-vec model, we have built an artificial neural network model to do the final classification. But now what we are doing is we are directly sending this to a large language model, getting the output without really building any model. Okay. Model building was from scratch. It is time consuming, but everything will be under our control if we are building our own model. But the flip side, the problem with building from the scratch is you need a large amount of data. If you do not have large amount of data, you cannot build a good model. Let us suppose if I'm just giving this as input, if I want to know whether it is positive or negative, all that I need to do is supply one by one review, and get the output. Okay. So how do I do that? Let us write the code for it. So what I'm doing is in the user review data, I'm adding a new column called predicted sentiment, and I'm taking each and every review and I'm using apply function. What is it doing? It will take one review at a time and then apply Senti model. From there, it is going to extract the label. So finally, every review will be getting one label. Senti model 2 is not defined. I think we have defined it as Senti model 1. Senti model 1 is also not defined. I think the model name, Senti model 1. So let me write this, that would be better. So user underscore review data, predicted sentiment is the review, Senti model. Senti model is also fine. That is the first model that we get. By any chance, did I crash this? But anyway, we will just redo that. Senti model. Right.
Sir, I think you are using capital S.
Capital S here.
Yeah. Previously, you were using small s.
Small s. Yes. So it's as simple as that. So what it is doing is it is taking our review and trying to get the sentiment automatically, whether it is positive or negative or positive or negative. This is what I mean to say zero-shot prediction. Zero-shot means we have not done any model building. We have not exposed any of our data. Directly, we are getting the predicted value. It works to a large extent for most of the general cases, but it may not work in every scenario. In scenarios where our data is very different from the rest of the world, in scenarios where our data is very, very niche, very much connected to a particular problem statement in a particular domain, then we may have to fine tune everything on our own. If you want to make these models run very fast, then you may have to load them onto CUDA. That means GPU. The additional command for that would be you have to say my device is equal to CUDA. That means you load this model onto my GPU. You have to make sure that you have a GPU running. If you have a GPU, then you can say my device equal to CUDA. Then this model will be loaded onto your GPU. Then it will work much, much faster. In some cases, I have observed these models are very much time consuming. They take a hell lot of time to give you the result. So to save some time, even the prediction time, if you want to save it, we can also load them onto CUDA. So that part of the code talks about your getting the results directly by using the model. There are several models on Hugging Face. You have computer vision based models. You have natural language processing models. You have audio models. You have video models. Several models are there. Mostly in our course or right now, a lot of the applications in the enterprise that I see, a lot of people are experimenting with these. Image, people are talking about this, but there are no immediate applications that you can implement in the companies. I'm talking about general enterprise companies that handle numerical data until now. They are now looking into the text data side immediately. Later on, images also people may look into them, but right now NLP is the whole focus. Like when somebody says Gen AI, even though it contains images, most of them are talking about large language models only. Audio is also there. Maybe that will be considered in future later on. So one of the tasks that we have done here is a sentiment analysis. Like that, you have different tasks in pipeline function. You can give any task which is mentioned here. These are all the tasks that are available right now. Later on, new tasks might be added. This is the task, question answering, summarization. These are all the tasks that are related to NLP, natural language processing. The task that we have used here is text classification. There is an alias for it. The alias is a sentiment analysis. So you can say text classification or you can say sentiment analysis. Both are one and the same. It returns the text classification pipeline. So like this, there are several models. If you want to do language translation, that is also possible. Let us see a couple of more examples. Let us suppose I want to do language translation model. So what will be the process? So I will say my translator model is equal to pipeline. You have to mention translation, like the task is translation from which language to which language. I would say English to French. And then you have to take the model that can do this task. Obviously, for translation, there is no better model than Google. Device equal to CUDA. This device equal to CUDA may not work in all our systems because we may not have the access to GPU. In my system, this will work because I have access to GPU because I'm using Colab Pro. If you are using Colab Pro, GPU access is given. If you are using Colab, maybe GPU access is not given. Okay. Then I would say my translator, let's say if I say good morning. So how do you convert it into French? First, the model is getting downloaded to 42 MB, 1.39 MB. The translated text is bonjour, or whatever it is, the French version. If I say good night, this is the one. That is a translator model. If you want to use it for Q&A based model, let's say question and answering, then you have to take the Q&A model. Let's say my Q&A model is pipeline. My task is question and answering. And then whatever is the particular model that I want to use. Let us suppose I have a data set. What do you mean by question and answering? You can give one document, text document. You can ask questions based on that document in the question and answering model. For example, if I have a document, let me download that document. So this is the computer scientist document. If I try to print what is inside this document, so it is containing about Alan Turing, information about Jeffrey Hinton, Ian LeCun. These are all the computer scientists. Jeffrey Hinton is the father of deep learning. Alan Turing is the one who pioneered all the computer science in the beginning. Jeffrey Hinton works for Google. I think he quit recently. Ian LeCun is a scientist who is in Meta, who works very extensively on these deep learning and transformers. Like that, you have several scientists and then information that is given as input. Now I can give that document as input. Now I can ask some questions on that document. All that I need to say is QA model. My question is, who is the first computer science programmer? Somewhere in this document, computer science programmer, let's say Ada Lovelace, somebody is there. So what is the answer that we get it? Ada Lovelace. So it is saying what is the matching score, because directly this may not be matching. So based on its calculation, what is the matching score? What is the starting point in this document? What is the ending point that it is giving? This is immaterial for us. This is the output that we are getting. If you want to ask any other question, let's say QA model, who is the father of deep learning? Let me ask that question. The context is document. Go through my document and tell me who is the father of deep learning. Jeffrey Hinton is the father of deep learning. So that is a question and answering model. This is a very primitive basic model. Later on, we are going to see very sophisticated way of question and answering. You can give a huge set of PDF documents And then you can ask very, very twisted, very difficult questions where the answer is present in 4 or 5 pieces in 4 or 5 different documents. All that answer will be extracted and all that answer will be synthesized into a proper answer, and you will get the final answer. That is a very complex one, which is known as RAG, retrieval augmentation generation. That is the most advanced version right now. Everybody is after RAG, which is coming up later on. This is a very basic version of Q&A. Q&A model is also available on Hugging Face. Just to introduce you to the Q&A model, we have used it.